All right, my goal in this video is to make sure that anybody that watches it has a deeper understanding of absolute value bars, what they mean and do in math, and how do we solve equations that include these bars in them. So let's start with the bare minimum. If you already understand the idea of absolute value bars, you can jump ahead in this video where I start solving equations that have those bars in them. All right, so step one, we got to understand what does it mean to say the absolute value of these two numbers, -4 and 4. Okay, so what I usually ask my students is, can distance be negative, right? It's a good question, and they'll come up with some really solid answers, and I'll ask them to explain why they say yes or why they say no. Can distance be negative? Now, ultimately, my viewpoint is that distance cannot be negative. It's got to be positive. If I walk this way 10 feet, someone says, you just walked 10 feet. If I were to walk backwards, they're going to say the exact same thing. You walked backwards 10 feet. The distance I traveled is always a positive distance. It's never going to be negative. So when we give absolute value bars in math, what we are asking, or what we're saying, is how far is this value away from zero? How far is this value away from zero? So let's just use a number line to represent this. So I could put 0 in the middle. 4 is right about there on the number line. -4 would be right about here on the number line. And I just ask my students, how far away is 4 from 0? And they say it's 4. How far away is -4 from 0? And what do they say? It's 4, because distance cannot be negative. So long story short, what do these bars do? They take the information inside of them. If it's a negative value, it's just going to turn it into a positive value because you're talking about distance. Okay, so we got a -4 in the bars. The answer here would just be 4. The absolute value of -4 is 4 because distance cannot be negative. So I'm going to create a couple of equations for us. We'll get started on solving those, and I'll show you exactly the steps you need to take in order to solve any equations, whether they're multi-step, one step, but if they include those absolute value bars, there's a few things you need to know. Okay, so let's start with something fairly basic like this one-step equation that includes the bars. So what I want you to understand is we are trying to find some number for x that when I take 4 away, I'm going to get 6 after I do the absolute value bars. So something -4 is going to give me a number. I'm going to take the absolute value of that number, and it should give me 6. We have to understand that there are two solutions to this problem. There are two numbers out there that I could put here, subtract 4 from, get a value that when I take the absolute value of it, provides me with 6. So here's what I want you to understand. Something -4 equals, if we could get this to come out to -6, the absolute value of -6 is 6. So what number -4 would give me a -6? What number -4 would give me a +6? Because absolute value of -6 equals 6. Absolute value of 6 equals 6. So we have two numbers to find. Now, this is such a simple one that I think most of us out there can do it mentally. So let's just start with the easier one. Something -4 makes 6. You guessed it, 10. 10 -4 makes 6. The absolute value of 6 is 6. Boom. So we know x can be 10, or there's one more answer. Something -4 that creates a -6. Something -4 makes -6. What's that something? Yeah, you guessed it, -2. So the fact that we're just mentally solving these is great, but I'm going to teach you in just a second, drawing a line down the middle of the equal sign and what you should do in order to solve as they get more complex, and we can't just do that mental math. So again, x is equal to 10 or -2. Both of those values will provide you with either a -6 in the bars or a +6 in the bars, but it doesn't matter if it's positive or negative because when we take the absolute value, all of our negatives just turn into positives. So either or would give us the value of 6. Okay, so now, if I asked you to solve this, I wouldn't expect you to just do mental math all the time. These are going to get more complex, You might have terms outside of the bars. You might have terms over on this side of the bar. You might have more information going on inside the bar. We need to know the steps to take algebraically to just isolate the variable to these two numbers. Just like any other two-step, multi-step equation, we're going to start by putting a line down the middle of the equal sign, separating left and right side of this equation, okay? What I want you to do is ask yourself, are the bars isolated? Have we gotten everything on the left side to go away except for the bars? If we have, we don't do anything. That line just gets erased, and we're going to split this into two separate equations. Why? Because we need to find two separate answers. It's a very simple thing to do. It's a very simple thing to memorize once you learn it. Here's how it works. Take the bars away, x minus 4. Write down the number it's equal to. On the second equation, take the bars away, but instead of saying it's equal to 6, say it's equal to the opposite of 6, negative 6. Now you've got two different equations. The reason we're doing that is because we're only left with bars, right? This information is inside the bars. So if we can get a negative 6, that's just going to turn into what we want it to, positive 6. So we can get this information to negative 6 or to positive 6. These are going to give us these two numbers that we already found mentally. Okay, so add 4, cancels, add 4, x is equal to 10. By golly, didn't we already have 10? Yes, we did. Over here, you would add 4. We're just using our inverse operations, which you should already have learned by now, because if you're moving on to solving equations with absolute values, you already have probably solved equations with distributive property, combining like terms, variables on both sides, all that good stuff. X is equal to negative 6 plus 4, which is negative 2. Perfect match. So this is how you're going to do it. You're going to split it into two equations. Set it up equal to the positive value. Set it up equal to the negative value. Solve each one of those equations separately, and then just go with the flow. Algebra will do all the hard work for you. Okay, let me give you a little bit more challenging one where one extra step is involved. Make sure we understand what we need to do first in those scenarios. All right, in this problem, something a little bit different because we have plus 5 as a term on the left side where the absolute value information is. That's different than what we saw in the past. In the past, we had just the absolute value bars. They were all alone with information inside. There was nothing else on the left side. Now that we have this extra term, we got to get rid of it. We got to move that information to the other side. We have to isolate the bars. We want nothing but the bars information on the left side. So how do I get rid of plus 5? I just take 5 away. Inverse operations, minus 5. This is stuff you've been doing since you first started solving equations. 9 minus 5 is going to leave you with a 4. Over here we have x minus 2 in the bars. So we have now isolated the bars. Okay, once you isolate the bars, it's time for you to split it into two equations. One needs to be equal to 4. The other needs to be equal to negative 4. And then you solve each of those equations and you're done. So this is a fairly basic one as well. X minus 2 equals 4. X minus 2 equals negative 4. You're just writing the positive and the negative values up here once you isolate the bars. So solve this one. Plus 2, x equals 6. Line down the middle, add 2, x equals negative 2. And those are the two values that would make this equation up here true. And last but not least, let's see if we can do a really challenging one where I have a term out here as well as a term being multiplied here. All right, welcome to the big leagues where we've got a bunch of negatives. We've got a number being multiplied by the absolute value information. We got a term over here subtracting 3 at the end, and it's equal to a negative 11. A lot of things going on here, a lot of possibility for error. We got to start by which part do I need to get rid of first. If we are trying to isolate the bars, we just want this information down here. We don't want that. We don't want that. We got to get rid of both of those. Now, let's go back to our early days of solving two-step equations. If I gave you 2x minus 3 equals negative 11, which part would you get rid of first, the negative 3 or the 2? Okay, hopefully your answer was you cancel out the 3 first. You'd cancel out the subtraction before you cancel out the multiplication. Same rules apply here. This is -2 times all of this. It's like a distributive property problem, right? -2 times, boom, boom. Similar to that, okay? We have to get rid of the subtraction first, just like we would in any two-step equation. So, how do we do that? We add 3, cancels, add 3. Now I've got -2 times the absolute value of x, 5x minus 1. This is equal to -11 plus 3, which is -8. I divide, because this is multiplication, I divide by -2. I divide by -2. Now I've got the absolute value of 5x minus 1 equal to a negative divided by a negative, which equals a positive. 5x minus 1 now needs to be split into 2 equations. 5x minus 1 equals 4. 5x minus 1 equals -4. Setting up the 2 equations, one equal to the positive value, one equal to the negative value, solve each one. Here we're going to add 1, cancels. 5x equals 5, divide by 5, divide by 5, x equals 1. Oh, you can't see that. I went a little too low. Get it low, get it low. There we go. And then over here, same idea. Add 1, cancels, but now we're adding 1 to -4, giving me -3 equal to 5x. Divide by 5, divide by 5, cancels. X is going to equal -3/5. X is equal to -3/5. There are your 2 answers. 1 and -3/5 are the 2 values that will end up giving you -11 once plugged in for the x. Hopefully this makes sense. Study hard and good luck on your upcoming test.